Hello students. So in the last video we discussed about ionic bonding, yes or no? Like the bond forms by two ions, two oppositely charged ions, cations and anions. That attraction is called as ionic bonding. But there is a second type of bond formation. What is that? Sharing electrons. That is covalent bond. So how can you define covalent bond, students? The bond formed by the equal sharing of electrons is called as covalent bonding. What is covalent bonding? The bond forms by equal sharing. What is the meaning of equal contribution or equal sharing? If an element gives one electron, other element also gives one electron. Here giving means not losing electrons, or nothing is gaining electrons, students. Here they are sharing electrons. What is happening here? They are sharing electrons. What is the difference? What is the principal idea between the ionic and covalent bonding? In ionic bonding, students, there is a cation formation and there is an anionic formation, yes or no? That means one atom loses electrons, other atom gains electrons, right? So that means electron clearly gets transferred from one atom to the another atom, yes or no? So we'll end up with a cation and an anion, right students? That is ionic bonding. Then what is happening in covalent bonding? In covalent bonding, electrons are not lost, electrons are not gained. These electrons, they share in between the two atoms. That means after sharing, both the electrons are still influenced by both the atoms' nucleus. That is the difference. What is happening? In ionic, one electron is lost. If this is lost, this electron has no relation with this nucleus, students. But in the case of covalent bonding, they are not losing or gaining. Still both the electrons are influenced by both the atoms. That is covalent bonding, and that is called a sharing of electrons. So what is the meaning of sharing? Both the electrons after sharing has influence of both the nucleus. That is covalent bonding. So that sharing of electrons is called as covalent bonding. So what are the factors, influences, what are the conditions, everything we'll discuss in this video. When is the bond between two atoms is covalent? So when we can expect this covalent bond, students? Like when is ionic possible and when is covalent possible? When ionic is possible, clearly we discussed in the last video that between the combining element, if the donor, that means if the element, the cationic formation element, it should have the low AP value, yes or no? And the anionic part, anionic element should have high electron affinity. That means between the combining element, one element should have high electropositive character and other element should have high electronegative character. Then one loses, gains, and they form ionic bonding. But here, when do they form covalent bonding? If between the combining elements, if the both the elements don't have a capacity to lose electrons or gain electrons, then they form covalent bonding. What is the condition, students? Between the combining elements, if the element don't have a capacity, if it doesn't have a capacity to lose electrons and if it doesn't have a capacity to gain electrons, then what is the next option for these elements to got? Ultimately why they are combining? To get stability, octet configuration, yes or no? So what is the next option? By sharing the electrons. So which elements don't have capacity? Electronegativity factor we discussed, yes or no? Between the combining elements, if electronegativity difference is less than 1.7, then covalent bond will be produced. Mostly between two non-metallic elements are there. Non-metals in general, what are their valencies? Either 3, 2, 1, yes or no? 15th group, 16th group, 17th group elements. So in general they want to gain electrons, but if non-metal are the combining elements, then which element loses, which element gains? They neither loses nor gains, students. They will share the electrons. They will share the electrons. How many electrons will they share? Same valency only. What is valency? Combining capacity of an element. If an element needs one electron, it shares one electron. If an element needs two electrons, it shares two electrons. If an element needs 3 electrons, it will share 3 electrons. If it needs 4, it will share how many? 4 electrons. And one more thing, if this element, if one atom is sharing 1 electron, definitely opposite atom also shares how many? 1 electron only. That is equal sharing. That is equal contribution. Understood? If this atom is sharing 3 electrons, opposite atom also shares 3 electrons only. Equal sharing of electrons takes place, students. So here, for example, as the electronegative difference between the two hydrogen atoms in the hydrogen molecule is 0. Transfer of electrons is not possible. Hydrogen molecule, what is the formula, students? H2. That means hydrogen bonded to hydrogen. Here, in these two hydrogen, which atom loses, which atom gains? Is it possible? Both atoms belong to the same element. Yes, sir, students. Does these two atoms have different electronegativities and different electropositivities? No, both are same. Both have same capacity of holding the electron. Yes or no? Then what will happen? They will share the electrons. That is called as covalent bonding. Understood? What is the main idea, main criteria which decides the covalent bonding? Electronegativity difference, right? So, representation of covalent bond, like I represented here in the previous slide. How to represent covalent bonding? Using a small line, like a hyphen, that is not called as hyphen, that is called as a bond. Remember, a bond indicates two electrons. A bond represents how many electrons, students? Two electrons. Two electrons are simply represented by this line. Understood? In these two electrons, remember, one electron belongs to one atom and other electron belongs to other atom. Simple, clear? That is equal sharing, yes or no? A bond represents two electrons. In these two electrons, one electron belongs to one atom, one electron belongs to the other atom. After sharing, both electrons belong to the both atoms. Understood? Both electrons, they are called as bonding pair of electrons. They belong to the both atoms. Why? Still they are influenced by this atom and they are influenced by other atom also, combining element. So, how a covalent bond is indicated by a line. The covalent bond between the pair of atoms is represented by a small line. For example, H2 can be represented as, you can see, look at the representation, H bond H. This is called as H bond H. H single bond, one bond, yes or no? Next, covalency. Covalency. The number of electron pairs sharing between two atoms of the same element or different elements during the formation of a molecule is known as covalency. Simply, covalency mean how many electron pairs are there which are getting shared between the two elements, or of same type or different type. For example, H2. In H2 molecule, how many electron pairs are there, students? How many bonds are there? Only one bond, yes or no? So, what is the covalency in H2? 1. In O2 molecule, between two oxygen atoms, there are two bonds are there, two electron pairs were shared between the two oxygen atoms. So, what is the covalency in O2 molecule? 2. In nitrogen gas, it's a triple bond. So, what is the covalency in N2? 3. That's it. What is covalency? The number of electron pairs getting shared in between the two combining atoms of same type or different. So, here the same examples are given here, students. Next, conditions favorable for the formation of covalent bond. The conditions we already discussed. Again, atoms should be of small size, yes or no? Atoms of big size, is it possible for them to share electrons? No. If atom is very big, what is its criteria? What will happen? It will lose electrons, yes or no? Most favorable condition is here. One more thing, sir, if atom is small size, it will gain electrons. If that is your doubt, correct. If both atoms are small size, then what will happen? Students, both atoms are small size, then which will lose, which will gain? Then they will share, yes or no? What are the condition of both atoms are big size? This loses, that loses, no. Or this will share, that will, no. That is also not possible. Why? Because for sharing, definitely nuclear force should be there, yes or no? That's why metals don't form covalent bond. Remember, they won't get octet configuration also. Covalent bond is expected between a metal and non-metal, exceptional cases like magnesium, lithium, beryllium, aluminium. And in general, covalent bond is expected between two non-metals. Got the clarity? So, atoms should be of small size. Why small size only, students? Why there is a reason for this small size? If it is a small size atom, nuclear force will be more, yes or no? So, they can hold this electron so tightly between the two combining atoms. Got the clarity? They should have high electron negativity. Yes. What is electron negativity? Students, factor. The ability to attract the electrons from the sharing pair is electronegativity. And ionization potential also very high. Ionization potential, if it is very low, what is a favorable condition? It loses electrons. But what is the point here? Ionization potential should be high. That means it cannot easily lose electrons. So that's why the electronegativity and the ionization potential of the combining element should almost be same, right? If one is low, ionization potential is low, electronegativity is high, then what is the bond they will form? Ionic. If both are equal, covalent. So, favorable conditions for the covalent bond formation is satisfied by the elements of 5th, 6th, 7th year groups, old notations, 15th, 16th, 17th group element, students. Non-metallic groups, yes or no? Nitrogen family, oxygen family, chalcogens and halogens, fluorine. So, these elements mostly they form covalent bonds. When they combine with metals? No. When they combine with other non-metals. For example, look at the examples here. Sulfur dioxide, sulfur oxygen, non-metals. phosphorus trichloride, phosphorus chlorine, phosphorus tribromide, phosphorus bromine, sulfur hexafluoride, both are nonmetals, sulfur dichloride, both are nonmetals, iodine heptafluoride. Yes, sir, understood, getting the clarity. Sir, why these numbers 7? That clarity I'll give you. O2, N2, F2, Cl2, Br2, I2, all these combinations are expected mostly between the non-metals only. Why? Because non-metals have high electronegativity values and high IP values, so they cannot easily lose electrons. So definitely for them the option is to share only. Got the clarity that sharing of electrons is called as covalent bond. How many electrons do they share? It depends upon the valency. If an element valency is 1, what is the meaning of element valency 1? It needs 1 electron. Whether by losing or gaining or sharing, it needs 1. Why it needs 1? In order to satisfy octet configuration. So that electron it will share. Got the clarity? Right. Next. Examples for the molecules having covalent bond. Look at the examples here. First example is given as chlorine molecule Cl2, students. Chlorine, what is the configuration of chlorine? Chlorine atomic number is 17. Its configuration is 2, 8, 7. 2, 8, 7. How many electrons are there in the valence shell? 7 electrons are there. Right, clear? More, how many it needs? More 1 only, na? In order to satisfy octet rule. If it needs more 1, what is the valency of that element? 1. It needs 1, right? So valency is 1. So it will share how many? 1 only. It needs 1, right? So each chlorine shares how many? 1 electron. Is it possible one chlorine loses, one chlorine gains? No. What is the option for them? Definitely they have to share. So they will share. Look at here. This dot here, for one chlorine dots were represented, for another chlorine stars were represented, just to differentiate between the two chlorine atoms, that's it. Okay, both are indicates valence electrons only. So this chlorine shares 1 electron, obviously opposite chlorine also shares 1 electron only. Look at how to represent. I already have told you Lewis dot symbols, yes or no? Look at here, to represent the covalent bond we used to represent by circling. How to circle? You have to circle the electrons of this chlorine atom as well as the bonding electron of other chlorine. Look at the circle. Similarly, from this chlorine side, you have to circle the electrons of this chlorine along with the bonding electron of the other chlorine. Understood? Now answer, between these two chlorines, how many electrons do they share? 2 electrons. Clear, na? 1 pair of electrons. Clear, right? In these 2 electrons, 1 electron belongs to one chlorine, other electron belongs to opposite chlorine. That is equal sharing. Got the clarity? Now, this 1 pair of electron is represented by a bond like this. Chlorine, bond, chlorine. What does it mean? It means chlorine, 2 electrons, they share in between. Understood? A pair of electrons indicated by 1 bond. 1 bond means 2 electrons. Understood, students? So this is called as single covalent bonding. Now, how do we confirm that it will achieve the octet configuration? Let us count the number of electrons. 1, 2, 3, 4, 5, 6, 7. Already 7 are there. Now look at the circle of chlorine. There is 1 more electron is there. 7 plus 1, 8 electrons, right? Now count the circle of this chlorine electrons. 1, 2, 3, 4, 5, 6, 7 of its own electrons and the 8th electron of other chlorine. Octet configuration or not? Now these 2 electrons, students, these 2 electrons, a pair of electrons, are influenced by this chlorine atom as well as this chlorine atom. Understood? That is sharing. Are they lost? No. They are influenced by the nucleus of both atoms. Remember, in covalent bond we can expect multiple bonds also, double and triple bond. I'll explain in the coming slides. This is a single bond. When it is a single bond? Between the combining elements, if 1 electron pair is shared, that is single bond, right? Next. Look at other example. We have HCl. Students, what is the valency of hydrogen? We already practiced valencies in the previous video also. Hydrogen atomic number 1. It has only 1 electron. Its valency is 1. It needs more 1 for duplet configuration. Chlorine, just now we discussed in the previous slide also. Chlorine also needs 1. Then look at the bonding. Look at the bonding. After the circling, what I told you, equal sharing. If one atom is sharing 1 electron, other atom also shares 1 electron only. So look at the circle of hydrogen count. 1, 2. Helium configuration or not? Look at the circle of hydrogen, 2 electrons, helium configuration. Look at the circle of chlorine, 1, 2, 3, 4, 5, 6, 7, 8, octet configuration. Now, how many bonds are there between hydrogen and chlorine? How many bonds? 1 pair of electrons only. Are these electrons participate in the bonding? No. Their valency only, but are they participating? No, no need. I already clearly explained in the previous video, sir, between valence electrons and the valency. right? So one pair of electrons means one bond, hydrogen bond, chlorine, HCl molecule. So next example we have is, students, H2O, water example, students. So hydrogen, one electron, this hydrogen, one electron, oxygen, see how many electrons are there in the valence shell? 1, 2, 3, 4, 5, 6. Already 6 are there, more how many it needs? More 2. Can it gain 2 electrons from one hydrogen? No, hydrogen can give only 1. So what will happen? They will share, this oxygen shares 1 electron with 1 hydrogen and another electron with the another hydrogen. Got the clarity? That's how they can get the respective noble gas configurations. Here, sir, why oxygen is not gaining electron? It is highly electronegative element, right? But what is, there is one condition. What is the condition? The electronegative difference between the combining element should be greater than 1.7 or equal to 1.7, yes or no, in order to satisfy, in order to qualify for the ionic bonding. If it is less than 1.5, 1.7, then obviously what is the point here? They have to share. So how many electrons are they sharing? Look at here, between the oxygen and hydrogen, they are sharing one pair of electrons, right? Here they are sharing one pair of electrons. Let us count the number of electrons in the hydrogen circle. 1, 2, helium configuration. In the oxygen circle, 1, 2, 3, 4, which are not bonding. 5, 6, 7, 8, which are bonding. Got the clarity? Total 8 electrons. And hydrogen, 1, 2, helium configuration. Now, remember, between hydrogen and oxygen, how many bonds are there? Between hydrogen and oxygen, how many bonds? One bond only, na? One pair of electrons they share. That means one bond. Between hydrogen and oxygen, one pair of electrons, one bond. So what is this bonding? These are single bonds or double bonds? These are two single bonds, student. These are two single bonds. Then how to say a double bond? If the two bonds are present between the two atoms only, then it is a double bond. Here between any two atoms, there is how many bonds are there? Only one bond. So single bond, two single bonds. Got the clarity? So now octet configuration, duplet configuration, all are satisfied. Next, formation of methane, carbon 2, 4. Hydrogen, we already know the configuration. Now how to circle this? Just simply circling the electron of this and bonding electron of the other atom. Helium configuration, helium, 2 electrons, yes or no? Now let us count the number of electrons in carbon circle. 1, 2, 3, 4, 5, 6, 7, 8. Octet configuration. Initially it has 4 electrons. After sharing it gets more 4. Gets means, is it gaining carbon? No. Still both the electrons are influenced by carbon, hydrogen. That is sharing. Understood, students? Sir, here carbon is, some students have the doubts like this. Sir, carbon is sharing 4 electrons now. Hydrogen is sharing 1 electron only. How it can be equal sharing? Listen, students, carbon is sharing 4 electrons, correct. But with every hydrogen atom, it is sharing how many? Each hydrogen atom, 1 electron only, na? Hydrogen also sharing 1 electron, that is equal sharing. Carbon with this hydrogen sharing how many? 1 electron, equal or not? With this hydrogen, 1 electron. Got the clarity? It is sharing 4 electrons and 1 electron? No, not like that, yes or no? So, now look at the bondings here. Between carbons and hydrogen, there are 4 single bonds. These are 4 single bonds. Bond. All bonds between carbon and hydrogens. Right, next. Students, multiple bond formations, like I said. So, between any two atoms, not only single bonds, students, even multiple bonds are also possible. Multiple bonds means double bond and triple bond also. The covalent bond found between the sharing more than one pair of electrons between the two atoms is called as multiple bond. If the covalent bond is found by the sharing of 2 pairs of electrons between two atoms, then that bond is called as double bond. When it is formed, depends upon the valency of the element. For example, look at here oxygen. It needs more how many? Like look at the valence electrons 2, 6 is the configuration. Already 6 are there. More how many it needs? More 2. Yes or no? Look at the other oxygen. Also more 2. Now each oxygen needs to share how many electrons? 2 electrons. Yes or no? Because they need 2. So this oxygen shares 2 electrons and this oxygen also shares 2 electrons. Equal sharing. Now look at here. Look at this in between. In between both the oxygens, students, how many electrons are getting shared? 1 pair? No. 2 pairs of electrons. 1 pair means 1 bond. 2 pairs means double bond. No, you cannot say 2 bond, double bond like this. O double bond. O, it's not equal to. Each line, each bond indicates how many electrons? 2 electrons. Here how many electrons are there? 4. That means 2 bonds. Yes or no? Students, now you can count the circles of oxygen, octet configuration. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Octet configuration. That's how. Depends upon the valencies of the elements, they can share either 1 electron, 2 electron or 3 electrons between two atoms. Maximum, how many bonds are there between any two atoms? It can be a single bond, or it can be a double bond, or it can be a triple bond also. But 4 bonds are possible between any two atoms, students? No. Why? I will tell you that clarity. Wait, look at here. In this example, nitrogen gas N2, nitrogen configuration 2, 5. How many electrons in the valence shell? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Already 5 are there. More how many it needs? More 3. Octet configuration. Already 5. More 3. Now each nitrogen shares how many? 3 electrons and 3 electrons. Got the clarity? If they shares 3 electrons, let's see whether does it get octet configuration or not. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Got the clarity? Octet. Now how many bonds are there between the two nitrogen atoms? They share how many? 3 pairs of electrons. 1 pair means 1 bond. 3 pairs means triple bond. N, triple bond, N. Now maximum triple bond only, students. 4th bond is not possible because when you go in depth in the coming academic year, you will have this clarity about sigma bonding and pi bonding. First bond is very strong bond. Second bond and the third bond are weak bonds. If there is a chance for the formation of 4th bond, that is the weakest bond. So elements, when they combine, they do not form weakest bonds, and there is no space also. When you consider the orbital concept of overlapping around the nucleus of both atoms, there is even there is no space also. Electron repulsions increases, that decreases the stability of the molecules. That's why maximum how many? All this concept you will get in the next academic year, valency bond theory. So remember, maximum 3 bonds only. Single bond means how many? 1 pair of electrons. Double bonds, 2 pairs of electrons. Triple bond, 3 pairs of electrons getting shared. In these 3 pairs, 3 electrons from one atom and 3 electrons from the another atom, right? Violation of octet rule. In the concept of science, in the subject of science, there are exceptions, violations everywhere, but don't confuse. Sir, why it is not followed? Sir, it directly questions the concept. Yes, sometimes yes. That is there everywhere. That is there everywhere in the subject, in the nature. So some molecules, students, they violate octet rule. What is octet rule? Every element show tendency in order to get 8 electrons in it in their valence shell. That is octet rule. Yes or no? Some elements, even after bonding also, they have less than 8 electrons, and some molecules, they have more than 8 electrons, which is a violation or not? Look at this PCl5 molecule. In this molecule, students, phosphorus has 5 electrons and it is sharing all the 5 electrons. So now how many electrons will phosphorus will get total? Already 5 and more 5. 5 plus 5, 10 electrons. But what is octet rule? 8 electrons. Sir, why then it is getting 10 electrons? Why? Because in the last video we discussed about energy concern, about the stability. Yes or no? Here that point dominates the octet rule. So if it can bond with maximum electrons, it can release maximum energy, so that it can convert into the more stable forms. That's why phosphorus should share 3 only, but it is sharing 5 because of electron excitations. Ultimately, by releasing more and more energy, if an element can form maximum bonds, that becomes more and more stable. That's why some elements, if there is a chance, do all the elements means no. There are some conditions. They should have some empty orbitals for these excitations. Then only they can change their valencies. Then only they can increase their valencies. Understood? So here this molecule is a electron rich compound. That means it has a number of electrons in the valency shell more than octet. And look at the other examples. SF6, sulfur hexafluoride, also 12 electrons are there. Sulfur is sharing 6 electrons. It will get more 6. Xenon fluoride, difluoride, trifluoride. Xenon is a noble gas. Yes, sir, students. The whole concept of chemical bonding is based on non-bonding of noble gases, right? But look at xenon. Xenon is reactive. You know why? Xenon valence electrons. What is the valence shell configuration of xenon? Students, 5s2, 5p, 6. That means the last valence electrons are present in which shell? 1, 2, 3, 4, 5. Here the valence electrons are there. Here if the valence electrons are present, does it experience much nuclear attraction? No. And there are empty orbitals also, 5d orbitals also. So this electron excites to that empty orbitals and it will get new valence. In general the valence is 0. But if it get 1 electron, the valency becomes 2. If it excites 2 electrons, and the valency becomes 4. So that's why xenon, atomic size is the reason for xenon reactivity. So that is an exception, students. And we have IF7, iodine also. Iodine belongs to noble, halogens, right? 1 is the valency, but look at here, iodine forms 7 bonds. That means because of this electron excitation, it can form maximum bonds. So here, what is the factor which is dominating here? Energy, right? Similarly, consider the formation of another molecule, BeCl2, beryllium chloride, BeCl2. Beryllium is a metal, right? Chlorine is a non-metal, right? What is our idea of bonding? When a metal reacts with non-metal, what is the bond we expect? Ionic, yes or no? But due to the smaller size of beryllium, for beryllium, it is covalent bonding. Not even beryllium, aluminium also, lithium also. Why? Because they are small size. Small size means, do they lose electrons easily? No. They attract easily, yes or no? That's why. So here, but how many, after sharing beryllium, does it get octet configuration? Means no. It has only 2 electrons in its valence shell. It shares 2, it will get to total how many? 4 only. It is less than octet or no? These compounds are called as electron deficient compounds. Look at other examples. BF3, boron trifluoride, AlCl3. Aluminium trichloride also has covalent nature, students, right? Bond pairs and lone pairs. These are also very, very important in the concept of deciding the shapes of the molecules. Bond pair, lone pair. What? Like bond pair, meaning a pair of electrons which participate in the bond. Lone pair means pair of electrons which do not participate in the bond from the valency shell. If an element have 100 electrons means doesn't come under lone pairs. From the valency shell, the electron pairs which participate in the bonding are bond pairs. The electron pairs in the valency shell which do not participate are called as lone pairs. So here some examples are given. Look at this example, this corner example. Oxygen gas, students. Here which electrons are participating in the bonding? Between 2. This pair of electrons, this pair of electrons. Numbers are given 5 and 6. Now these are called as bond pairs. Look at this pair. Look at this pair. This one. Are they participating? No. They are called as lone pairs. Got the clarity, students? So how can you define this lone pair and bond pair? From the sharing pair of electrons which result in the formation of a bond are called as bond pair. Simple. A pair of electrons which participates in the bond. Lone pair of electrons. A pair of electrons present in the valence shell but do not involved in the bonding. Simple. They are also called as non-bonded pair as well as lone pair of electrons. So let's see some examples here, students. O2 molecule is done. Look at here. Look at this example, H2O. Can you identify the number of lone pairs and bond pairs in H2O? This is lone pair or bond pair? Bond pair. This is bond pair. This is lone pair. This is lone pair. 2 lone pairs and 2 bond pairs. Yes or no? That's it. A pair of electrons which participate are bond pair, which do not participate are lone pair of electrons. So students, that's what about covalent bonding. I hope you got the clarities of all these points, like what are the conditions, what are the factors, influences, what are the examples, what are the violations also. So in the coming video, we discussed about the physical characteristics and coordinate covalent bond, all the remaining points in the coming video. Thank you, students.